Welcome again to another tutorial. We spoke about this diagram one time, but from the comments there was much confusion and it's a little hard to absorb the details of this. Basically, we're going to a fuel pump. This is the fuel pump, the symbol for it. In this case, we're going through an inertia switch, which is very rampant and popular with Ford vehicles. In case there's an emergency upon impact, this opens up the circuit, opens up obviously the fuel pump, and you have no fuel going to the injectors. A safety valve. One time we have a relay going to the fuel pump, as you see over here. Fuel pump, inertia switch to the fuel pump. Fine. Here in this diagram, it's a little more complicated. We have two, almost like two in series. Now, as I said before in the other one, this controls this one. This is based on this one. Let's start with the basics. We need current to flow from the battery, hot and start or run. We go from the fuse through here, follow the green arrow through this to ground. So we have 12 volts here from the battery to here, 86, and then 85 is connected to ground. So let's take this so we understand a little better. Okay. Now, as you can see over here. Now, 86 has the 12 volts on it. 86. Other one is the ground. 85. So therefore, we have current flowing through it. Now remember, this can be opposite also. 86 could be here, 85 could be here, depending on the make and model. It doesn't really matter. As long as you have 12 volts going to one end and the other one is going to ground. Doesn't matter. We look for 12 volts at the coil. This is the image of the coil. See the coil? This one. Now, when we get to this switch has to close when this has a magnetic field which has current going through it. We have current going through it. That means this switch has to be closed, the contacts. Now, the switch 30 is this point over here. 87 is this point, the switch being closed. Forget about 87A. 87 is this one. This is closed. 87 is connected then to 30. This switch is closed. 87 is then connected to 30. Fine. That's the same thing. This one over here, same thing. As you can see, same thing. 30 and 87, same thing. We need this to be activated for coil, for current to flow through it, and then this switch is flipped over. See, it doesn't make a difference of the relays. The same concept. Now, taking this into consideration, we just said that current flows here. Fine. This switch will close. Okay, fine. Now, current will flow through this fuse. Follow the green. Through here. Through here. Now, the problem is, where's the current going to go? Current is looking for a path to find to ground. To control computer, we don't know if that's a ground. We don't know what it is. So we can't say it'll take this path. Let's start. Since there's no connection here, we don't know what it is. We have to take this path of current. Let's take this path of current. Goes to another relay. And then, as you see over here, it's stated over here, ground from control computer. Okay, President start. That means that we found the path to ground. That's what the current wants. Even though the computer gives us a ground instead of a physical ground, that's okay. Current doesn't care. Current says as long as I have a path to go from the battery positive back to ground to the negative of the battery, I'm happy with that. So he complies with us. The computer gives us a ground. In that case, current flows here, through here, again, closes this switch. Now current can flow from here, from the fuse again. Remember, some went here, some is going here. Through here, now this is closed. 30 and 87 are closed now. Now we have current flowing through the switch to the fuel pump. So, what determines him? is the ground from the computer. The computer determines if the fuel pump can run. How? By giving him a ground. And what else? By giving him a ground, he's allowing current to flow through here. Now, the reason I went over this again, a comment was stated, actually sent. What's the purpose of to control computer? Cannot be a ground also. Well, let's analyze that. Can this be a ground? If this is a ground, right? Current flows here. This closes. 30 and 87 is now going to ground. Okay, fine. Could go to ground? No. Because B plus is connected then to ground through a switch. That's a short right to the battery. Remember, this is connected to the battery. The battery is here through the switch, no resistance, and to ground. That's a short circuit right across the battery. So it can't be a ground. It can't be. So, what's another option that we have? And number two, even if you would say it's a ground, which it obviously can't be because of what I just said, but also, even if it would be a ground, where's the current going to flow? It eventually has to go to the load. The load in our case is the fuel pump. There is no fuel pump here. So what is this really accomplishing by closing this? Nothing, except giving us a short circuit and giving us problems blowing the fuse. So no ground here. I see in many vehicles, or some vehicles I should say, make models, two together, right? In case this malfunctions. The computer, as you see over here, look where it's connected to. The computer could give a ground. The computer could give 12 volts. Sometimes it gives either 12 volts or a ground. But to control, if this is not working, let's say we sense it doesn't work. How will it work? 12 volts over here. And if this is ground, how much? 0 volts, ground. How much over here then? 12 volts or 0 volts? If you said 12 volts, you're correct. Why? We're connected to the battery through the switch, through the fuse. How much over here then? If this is 12 volts here, how much over here? If you said 0 volts, wrong. This is just a switch. There's no voltage loss across here. 12 volts here is 12 volts over here. Now, let's say it doesn't get 12 volts from this. It senses, you know what? The computer says, you know what? I didn't get 12 volts. This relay is not working. How about if he gives you 12 volts? The computer will say, okay, forget about him. I'll give you 12 volts to ground. What will that do? Close the switch. What will that do? Current can flow now through here to the fuel pump. So we have a backup. We have this that can take the place of this if this is not working. Seen it very rarely, but I've seen it. So the computer could toggle both 12 volt and a ground. It could go to the computer, but the computer could also give back 12 volts. So now, as far as troubleshooting, and I always have to bring this to this, like I said, I made a video about how to test relays in circuit. Where would you go to test? Where's a point that you think you can test? Like I made in the video. Always go closest to the load. Inertia switch, that's in the back of the trunk. We're not going to go there. Fuel pump, forget about that. That's in a fuel tank. We're not going to go there. Always go to the closest to the load. This is the point. Where would it be over here? 87. Where's 87? 87 is right here. When this closes, I know this is working. So if you look over here, I don't know if you can see it. It's going to be very difficult to see it. 87 is actually this one. 87 is this one. You would take this probe, like I did in the video. I put a piece of wire there in the terminal, and then I put this full into it. And I measured the wire that's making contact with this. Why did I do that? That told me if I have 12 volts here. If I have 12 volts over here going to the pump, what does that tell you as a viewer? That tells you this is working. What else does it tell you? What's another thing that should come to your mind as a viewer? Why is he closed? Because this is working fine. Why is he working? Because the ground from a computer gave us a ground. That's the answer. That's the best answer. But what else? Because he's working. What else to that? If you're going to say the fuse is good, that's also correct. What else? Because he's working. And why is he working? Because the fuse is good. Let's go backwards on that analyzation. Fuse is good, then he'll work. If he works, then he'll work. He'll work because he works. He will work because he works and the computer works. Computer works, then he will work. And then once I measure 12 volts at this point, once I go to 87 over here, guess what? I have isolated all the problems over here, that all this circuitry is good, including our computer. Very important, including our computer, right? Now, from what I just told you before, you can say, okay, if I do that, if I do go over here, put 12 volts, maybe this is not working, but maybe the computer turned this on. Could be. That's why, in this case, I would say, you know what, let me go over here, but also let me go to the other let me go to this point over here, 12 volts, and these two. Usually it's good enough to go over here, but I want to make sure that he's working, and he's working. He's turning this one on. Therefore, we'll go first here, 87. Again, 87. Now let's say this is the relay for this one. Let's say I have another relay for this one. I will go here, 87 like we just said, and I would go 87 and 30. Then for this one, I would go 87 and 30. And how much should I get? 12 volts here. 12 volts over here. Okay? That would tell me that much. But in a real one, if you only have one relay, right? Let's say this wasn't a backup, whatever it is, whatever the situation is. As long as I know that I get that this is working, that tells me the computer is working. That's the most important part that you should come away with from this video. That's, I think, what was confusing. Once you go over here, it tells me this is working. Not only this is working, he's working. Not only he's working the fuse. Not only is he working, he's working. Fuses, grounds, everything is good. What could be the problem? If everything is good here, where do we go? To the inertia switch and to the fuel pump. In many cases, obviously, these open up and the customer really doesn't detect it. And it's an easy fix, it sure is, but you have to be honest. That's the problem. The inertia switch open in this case. So that's the best way to go troubleshooting. Okay, let's say I have 12 volts over here. I have 0 volts over here. Okay, and the first we said, fine, 12 volts over here. That means all this is good. Let's worry about the switch. Let's worry about the fuel pump. Okay, great. Let's say I measure 0 volts over here. I take the relay and I measure 0 volts. And again, if you want to jump a relay, again, I don't recommend jumping relays. I think you've seen enough videos from me. I don't recommend it. It's been done too many times from customers that do it the wrong way, and then computer goes bad, more money. But if you want to do it, which one would you jump? Never jump a coil. Always a switch. Jump here to here. This one, all the way to this one, at the bottom over here. At this one. This to this. On this one. Okay? If you want to jump it. Now, again, 0 volts. I put my meter over here, 87. Over here, I measure 0 volts. Oh, no. Problems. So it can't be the fuel pump. Fuel pump is not getting the voltage. 0 volts. What's my next attack? Do you think? As a viewer, what would you think you would go? Should I go over here to the 12 volts? Should I go over here? Well, if I go over here, all it's going to tell me is the fuse is good. That's it. It's not going to tell me anything about this. My next attack is to make sure that the computer is giving us the ground. Make sure I have 0 volts over here going to ground. If this is 12 volts, that means this is floating. No current is flowing. I should have 12 volts here. You see here? 12 volts here. 12 volts here. 12 volts here. And 0 volts because it's a ground. So if I have 0 volts over here, computer is doing his job. something is failing ahead of this. Then I have to backtrack over here. But very important, like I said before, stress the point. Computer give this a ground. He works. It's a complete path for current. Then he works. Then he works. If he just gets a magnetic field and there is no path for current to flow because there's no ground, current will not flow and needs a complete path. Doesn't matter that this is closed because of this. Doesn't matter. Doesn't matter. You need a ground to complete the current. So keep that in mind. I hope this will clarify many of the confusion and the problems I got in the comments. Like I said, always go by my technique. Go to that video of starter motor. Go to that video that I did hands-on on fuel pump. Everything in circuit. Like I said, the views for that one got a little better. Understand what I'm doing from these schematics that we just went over. I think it'll be easier for you to understand what I was doing. Regardless of the make and model, they're all the same concept. Fuel pump relay, same thing. It's the same concept. So if you want to know the last point, always go to the last one closest to the load. The closest one to the load is 87. This one right here. See? It's like it's flip-flopped. If you look at it this way. See? 30 is over here. And 87 actually is this one. See? But don't make the mistake. Remember, because it's flip-flopped. This is the one that's toggling. This is the one that's toggling, not this one. This is the switch position, the contacts, going from here, 87A to 87. Not this one. If you diagnose this one, you're going to diagnose it incorrectly. Go to my channel, go to my videos, hands-on how to measure, how to test fuel pump relays, starter motors, battery test, load test. My channel, Automotive Electronic Schematics by Joseph. That one I'm trying to get more views. And the other one, Joe Electronic Schematics for Auto. Thanks for watching. Hope this was helpful and informative. Please leave a like or a comment if you liked it.